So this is what we're going to try to make happen. This is from a scan of me with Kinect and then stuff made in Blender. Delete everything. Let's import that OBJ. So the OBJ was scanned using ReconstructMe, which doesn't run in Windows 8, it runs in Windows 7. And the resulting mesh has a bunch of problems. Let's just move it around some. Control A location to move whatever, S.1, enter to scale it down by a tenth. So now it's about, I don't know, 70 millimeters across. The ReconstructMe OBJ had 1 unit per millimeter. Let's try to rotate it some and approximately center it. So the way I scanned this was I was sitting in a chair and I had ReconstructMe running and the Kinect sitting on a box on a table facing me, and I swiveled around in the chair. There's some artifacts I'm not going to clear up, like this line across my face is from where ReconstructMe didn't match up me to me again accurately, because it has to stitch together the bunch of different views because you're rotating around. It has to put that all back together. There's this big hole in the top of my head, there's this hole here, there's this cowlick, there's holes in the headphones, holes in my neck, holes in my hood, holes in the chair, a giant hole in the bottom. These all need to be filled in to be able to do anything useful with this mesh. My plan is I'm going to build that platform, I'm going to build the text, and I'm going to make this one solid and watertight, and then use booleans in Blender to put that all back into one. So let's start working on making this watertight. So I found this website. I was searching for, I don't know what I was searching for, probably mesh repair. And it has a link to a bunch of applications for repairing meshes and so on. And I'd seen MeshLab used before, but I didn't find a tool to fill in all those holes in MeshLab that did a very good job. What I ended up using is Polymender, which is a console application, which I'll show you in a second, that takes the input mesh, builds a voxel world out of it, and then based on the input mesh indicates the inside and outside of the mesh. And then it uses that to rebuild the entire mesh itself from the voxelized Octree world version of it. And so that'll result in it filling in all the holes and it taking a mesh that's really broken and too complicated and making it smooth and continuous. So this will fill in all the holes. It won't create something perfect for my needs because it'll come back as more than one watertight solid. So what I'm going to do is delete all the other parts that aren't the main part because I don't care about things floating off in space. And then the problematic parts, the cowlick, and there will be a big crease around the headphones, will be cleaned up. This will all be sliced off around here for the podium. There's a hole in my neck. So let's make that happen. First, so let's save this as YouTube. This is my second attempt. The first one I lost the audio from, and I don't feel like dubbing over it again. So Polymender is not the slicing software. If you shift right click in Windows 7 or 8, there's also in Vista, there's an open command window here. When you download it, it's a bunch of console applications, and let's go through the commands. So we have input file, which must be a STL, ASC, or PLY. We can output from Blender, STL or PLY. Octree depth is the specifies the number along each dimension that the world is sliced into. However, it specifies the 2 base log of it. So you specify 5 and it does 2 to the 5th across X, Y, and Z. So 5 might be a bit low because that's like 32 or something. We'll go with 9 because I played with it earlier and that was about the right one. 10 was a little too much detail in the resulting mesh. So you'll end up getting something with even more little lines in it than what we're starting with right now. So let's export APLY as, we're going to spell YouTube wrong because this is my second attempt. Then I get to find it in the list. Shift right click, copy as path. Polymender, paste. We're going to do an octree depth of 9, a scale of 1.0, which I played with and it seemed to make stuff softer when I used a smaller scale. An output file of the same file but underscore polymended. And then the next 2 parameters are optional. Cool. So move our original mesh to layer 2, then I'm going to import the output mesh on layer 1. The PLY import actually takes a bit and also uses a bunch of memory. So if I had the octree depth set up too high, not only would this file be a lot larger, but the import would take a lot longer. I don't know why this is so much bigger. Nor do I know why it's rotated. I probably forgot to apply the scale or rotation. Or location. Or I imported the wrong mesh. Yeah, that's a bit too high. Let's try this again. You apply. Export PLY, U. So we're taking the, that's the correct one, that's the correct one. Let's run it again. Go back to layer 1. That looks better. So there's our original, there's our polymended mesh. Notice the hole in the headphone is closed, the giant hole in the bottom is closed, the holes in the top of the head are closed. It might be too high of an octree level as well. Yeah, that's too high. Okay, let's delete it. Do it again. Eight. So it still looks pretty high, but it doesn't look overwhelmingly so. And it's just choppy on this machine. It's not really, really choppy. I think I'll leave it like this. Okay, so next there's some things I wanted to clean up. So I wanted to delete all the floating things that aren't part of the main mesh, which are kind of hard to show you. If you hit L in edit mode, it'll select everything linked to the vertex nearest your cursor. So notice these black parts aren't selected. I'm going to hide that and just select and delete everything else. Next, I want to clean up the stuff on the top of my head. So the box selection was B. Shift-H hides what's not selected, just so it can be faster. Let's go to solid mode and start. Yeah, I can start with the cowlick. Control plus grows the selection. Middle clicking when doing a box selection will deselect. The problem with those vertices is that they're obscured. So pressing this toggles whether you can see and select obscured things. I'm going to smooth out the cowlick. I can smooth it 9 times. Next we're going to work on this part. Not really being too precise about the selection here, because what I'm going to do is grow the selection to include what I want. And then do the same smoothing. Nope. Yeah, that's probably fine. See how that turns out. There's still some spiky bits. The topology is probably more to blame than the... Cool, let's start working on everything else then. F2 is save as, plus on the numpad increments the number on the end. Enter. So I added a plane, S25 enter. So the plane started off as 1 unit going from the center in each dimension, so it was 2 unit square. So now I have a 50 millimeter by 50 millimeter plane. Just trying to make the bottom part of the base. Then I'm going to move both of these up. Actually, yeah, now I'm going to move both of these up 15. No, let's go 10. And then I'll use 10 for the base. So extrude created the extra ring of vertices, but I canceled the grab mode after that. Let's make the base a bit wider. That's cool. Apply location, apply rotation and scale. That doesn't matter for that. So what I'm going to end up doing is doing a boolean to union these two together, and also do a boolean to union the text with it. So let's add the text now. Let's go to a different layer and move the cursor to center and change the view to a top. Text. Tab enters edit mode on the text. Text has its own properties. We're going to start with bumping the size all the way up, giving it a little extrude. Let's move that back to layer 1. Position it approximately in place. Is that big enough? It could be bigger. That might be a bit big for it because it'll stick out the bottom now. Well, that's because my extrude is too high. It's looking pretty good, actually. Let's save. Alt-C, mesh from text. So what I found out before is that when you convert text to a mesh, it actually converts it to a bunch of disconnected sets of vertices. So if I hit L, it'll select only the extrusion portion, right there. This is only the bevel portion, and then there's also the just inside part of the text only. So what I'm going to do is unhide everything, select it all, and then remove doubles, which will combine all of these vertices that are right on top of each other into the same vertex. Then I'm going to start booliening everything together, because I think this is looking pretty good. Let's give this a name. That's fine. Let's move these to other layers. So I'm moving the stuff I'm going to boolean back into the podium to other layers. Yeah, I can state names plain. And then I'm going to use the boolean modifier. The boolean modifier is kind of slow and has crashed before, so I'm going to save first. I'm going to union the podium with the cleaned up imported mesh. By which I mean okay, that's different. That wasn't a union. Okay. Layer 3, enter edit mode, unhide, recalculate normals, outside, exit edit mode. I expect the reason it's taking so long to respond right now is that it's doing the boolean again. No, it's because I hit mirror. Layer 1, still weird. Intersect should only give us the places where both of them are. Oh, I know what's going on. It's easy. Hilarious. We'll recreate this in a second. So the normals on my podium are going the wrong way. Let's try this again. So that's looking good. Yep, so all the mesh stuff going on in here is gone. And let's hit apply. And what we're going to do next is just delete all that stuff off the bottom that I don't want. Tab to enter edit mode. 3 to go to the side. Box select the bottom. Delete just the faces. Create that face again with F. Control N. So I should have something that's solid and a single mesh. And in edit mode at least, you'll see the wires going to this thing. Let's do the boolean modifier again. We're going to union with that text. And it should stick out of the front, but we should get nothing going on inside. I wonder if that's going to be a problem. No, it actually looks like the Boolean did the self-intersection correctly. Cool. We'll see what the slicer thinks. Another useful check, which I needed to do before, but I'm not sure I need to do this time, is hit Ctrl-Alt-M in edit mode to select non-manifold, which will select all edges that have fewer than two faces or more than two faces. A manifold mesh should have just one two-face on every edge. But if you have a T-junction or you're missing a face, like if we had left the face off the bottom, that part would be non-manifold, and then when we export it would be non-solid, and then Slicer wouldn't be happy. So I'm pretty happy with this. Let's just do some cheesy things to make sure it's the right size. So the right edge is over here. If I move it over there, I'm just using this as a cheesy way to measure. I moved it 35 units along the x-axis, which is about 35 millimeters, which is fine. And if I move it down on the z, it's 53 millimeters tall, which is fine. So I should be able to print this okay. Save it again. Let's export an STL. For.stl. So let's start up Slicer from scratch. So we're using Slicer with our riprap. Our config is in this same folder. For this, I'm going to drop the fill density to 0.2. And then slice that STL we just exported. See if it complains about anything. Dun dun dun. Dun dun dun. Dun dun dun. So let's try something. So there's the G-code it created, and there's this thing I found online, which was the second link on Google for G-code viewer. And this one has these blue lines, which is cool. If you drag a file in, it'll do the file upload, and then it'll view it. Okay. So That's interesting. So what Slicer does when it finds problems with self-intersecting faces is that it repeats the same layer over and over. So if you remembered, our podium was angled straight. How do I zoom? Whatever. Our podium was angled, but this group of layers is all repeating. And we're having the same problem right here. And I believe right there. So this would probably look just bad when we printed it and not terribly broken. But I can use the same polymender approach to clean it up. So let's do that. So we're back here at polymender. We're going to take our now let's just start over. Delete it all. Polymender, we're going to import our STL file directly. The next argument was depth. Let's do 10, 1.0. This will be a huge number of polygons. So I just moved the original object to layer 4, import ply. Oh, that might be a problem. Let's do that again with a 9. Okay, so this one will take a minute or two. But pretty much all we're going to do is look at it, make sure it looks like the way we want, and then export it as an STL, and then load that into Slicer and see what happens. I probably would have had better luck using an actual 3D modeling, solid modeling package instead of Blender, which is a computer graphics modeling package. Yeah, that's pretty dense. I don't know that those kind of details that Polymender did to chamfer the edges and stuff are actually going to turn out to be a problem when we 3D print this, because this is printing to be pretty small. So let's export that as an STL. We called it YouTube 4 underscore. Exciting. F2 plus enter. So there's our STL file. Oh, it's getting pretty big. Copy as path. There's Slicer. Slice that thing. And again, it thinks it's crashing. It's only 1.9 million faces. Aw, we killed Slicer. Well, let's do it again with an 8. That's probably still fine. So now our STL file is 24 meg. Let's reload Slicer. Reload our config. Set the fill density back down to 0.2. Slice. And then once it's finished slicing, we'll bring it into the viewer again and see if it looks good. And then I'll head up to the hackerspace and try printing it. Most exciting progress bars ever! This one should only be 500,000 faces. Do I win? No! 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 The text is all broken. Oh, let's try something. Aww. Well, I don't know. I am stumped. Let's load up my one from earlier. Yeah, I'm not seeing any repeated layers on this one. And if you tilt it right, you can sort of see the text down there. Sort of read it. I am not going to stress too much about it since I have this one to print, but hopefully you guys don't get stuck in the same problem. I expect what I can do with the one that it didn't like is import it into MeshLab, and there's a select self-intersecting faces. Filter, selection... I see.